This video is going to expand upon what we learned in our last session by kind of taking the inequality concepts that we've learned and going a little further with them, making them a little more complicated or making us work backwards. In this picture, I have given you the graph. You see the graph already, and I want to know what the equation or the inequality in this problem originally was. So you kind of should break this down piece by piece. First of all, it's easiest if you have y by itself, so I'm just going to have y, and I'm going to have my sign right here. So to figure out my sign, I know I shaded above the graph, so I'm going to be seeing either a greater than or a greater than or equal to, and it's a dotted line, so it's just greater than, no line under there. Well, it's mx plus b on this side. I know my slope, down 1 over 3, is negative 1/3 x, and then my intercept was at 2. So you can work backwards. If you have a picture, you should be able to, and I'll definitely ask you, to be able to provide the inequality that got us that picture, working in reverse there. I want to talk about what it means to actually be a solution, and what it means to be in the shaded part versus in the nice, or in the white part versus in the shaded part. And I'll write down the note first, and then I'll show you what I mean by it. So, points in the shaded area are solutions to the inequality. Points in the shaded area are solutions to the inequality. And I'm going to show you what I mean by that by picking a point that is in the shaded area and a point that is not. Let's say I took the points. Let's go with 0, 0 for now. Do a couple of points right here. If I plug in a 0, 0, 0 is right here. It's not in the shaded area, which means it shouldn't be a solution to this inequality. It shouldn't work. I'm going to plug in a 0 here and here and see what I get. So 0 greater than negative 1/3 times 0 plus 2. I end up getting 0 is greater than 2, which doesn't make sense. 0 is not greater than 2. So the point 0, 0 is not a solution. It didn't work in my problem. Next up, I'll pick a point in the dark area. So if I look at the points, I'll go with 3, 2 right here. So if I check out 3, 2, if I plug in a 3 for x and a 2 for y, let's see what happens. I get 2 is greater than negative 1/3 times 3 plus 2. I get 2 is greater than negative 1 plus 2 is 1. 2 is bigger than 1. That worked out. So this point in the dark area is a solution, because it worked when you plugged it in. And finally, I'm going to pick in one point that's on the line, and we'll see what happens there. So maybe if I pick the point 0, 2. So I would get, if I do 0, 2, I'm going to have 2 is greater than negative 1/3 times 0 plus 2. I end up with 2 is greater than 2. So this isn't true. 2 is not bigger than 2. If this was greater than or equal to, then it would be good, and that's when we would have a solid line. So if you're a point on a solid line, you're good, but on a dotted line, it didn't work out. So that's no good either. Points in the dark area are what work. I want to close out this video here by talking about a couple absolute value inequalities. There's nothing that says inequalities have to be linear. You could be looking at something like one of these problems here, and I bet you could figure these out on your own already based on your knowledge of just standard stuff that we've talked about already. But I'm going to walk through it right here. First thing I'm going to do here is look at where my graph moves. This moves at left 4, doesn't go up or down at all. So I just go left 4, and then I go up 2 over 1. It's going to be a solid line on my graph here. And I want to shade below my graph. So it's a little bit stranger to shade below it. Pick a point on the graph, and the part underneath it is what gets shaded. So all this gets shaded here. And this graph I'm going to draw over my picture here is going to keep going like that. So technically all this part here would be shaded too. Almost the entire picture. The stuff that's not shaded is the stuff inside the V on top of the graph right here. On my second example, we don't really deal with graphs where y isn't by itself. I'm going to get that 3 out of there so I can be dealing with a regular problem. I get y is less than x minus 1. You know what? I'm going to change this to a greater than problem. Sorry, just so you can see what that looks like too. Y is greater than x minus 1, and then a minus 3 out here. So according to my new greater than problem, first of all, I'm going to go right 1, down 3. I'm right here. I'm going to go, there's just a 1 here, up 1 over 1 in each direction. Notice I'm using open circles because it's going to be a dotted line. And since I changed this one to a greater than, you put your pencil on the graph, go up. This middle inside triangle part is the part that gets shaded in this one. And the final question here, they want to know, is 0, 0 a solution to either inequality? So you could plug in a 0 for x and y and solve, or you can just look at the graph. 0, 0 is in the shaded area here. It's also in the shaded area here. So it turns out that it is a solution to both because it's in the shaded area.